In this video, we are looking at what we call the mean absolute deviation, sometimes just called the MAD. Let's be sure our page is all set up. We have our margins, and we're going to add our date and our topic, which is mean absolute deviation. For our essential questions today, we're going to be asking and hopefully answering what is the mean absolute deviation and how do we calculate it? Like a lot of things that we've done in this unit, the MAD gives us a sense of how spread out the data is. This is just one more tool that we have in our toolkit as we describe data. This one tells us something that sounds a little more complicated at first. It tells us the average distance each data point is from the mean. In other words, on average, how far are each of the points from the mean in a set of data? So why would we need to know this? It's best to do this by showing you an example of two data sets. So when we look at the MAD, or mean absolute deviation of both, we can see what information that's telling us. On my next page, I'm going to give you two data sets. I have these two data sets. In both of these, the mean is 5, but they look very different. First of all, let's just double check that the mean is in fact 5. So I'm going to calculate the mean. I'd like you to do the same thing. And when you're finished, unpause and just double check. Great. So both of these have a mean of 5, but they're different. We know they're different. The numbers in this set look different. Let's take a look at them in line plot form. In set number 1, the points are all really close to each other, and they're really close to the mean of 5. In set number 2, not only are they spread apart from one another, but they're much further away from the mean of 5. In math, we have a way to describe how far these points are from the mean, and that's our mean absolute deviation, also called the MAD. Let's see how we find it. I'm going to make a table because I love using tables to organize information. I'm going to do that on my next page. Okay, so I have my tables ready to go. I need to remember, of course, that our mean for both of these was 5. Right? That's going to be important as we calculate the MAD, the mean absolute deviation. I filled in the numbers from the first data set into my table. Now I want to find the distance of each of those points from the mean. Now, we don't care if it's smaller than or more than the mean. We just want to know how far it is. That's what it means when we call it absolute. We'll work with that term more in other units this year. Let's do the first set. 4 is 1 away from 5. This 4 is also 1 away from 5. 6 is 1 away from 5, and the other 6 is 1 number away from 5. The total distance of all of those numbers away from the mean is 4. When I want to find the mean distance, then, I'll take that 4 and I'll divide it by the number of numbers, 1, 2, 3, 4, just like we do with any mean. So I'll be dividing 4 by 4, and I get 1. The MAD, or the mean absolute distance away, is 1, right? And that makes sense, because when I look at my line plot, the numbers were 1 point away from the mean. Let's do the same thing with the second set. I'm going to put those numbers in here, and then I need to see how far away they are from the mean. Well, 1 is 4 away from 5. 2 is 3 away from 5. 8 is also 3 away from 5. And 9 is 4 away from 5. Remember, I don't care if it's more than or less than. I just want to know how far apart they are. This time, if I take all of those numbers and I add them up, I see that altogether the total distance away from my mean of 5 is 14. Right? There are still 4 points, so I'm going to take my 14, divide it by my 4 numbers, and find my average, find the mean. This time it works out to be 3.5. Our MAD is 3.5. This makes sense if I look back at my line plot because the points on the second line plot were much further away and spread out than that of the first line plot. What this tells me is that the second set is more varied than the first. The points are more varied, the points are more spread out. We also say that there is more variability. We found that by finding the mean absolute deviation of the data sets. We found the distance of each point in the set from the mean. Then we found the mean of that distance to see on average how far each point was from the mean. Before we finish, let's do one more MAD. I'm going to turn my page, I'm going to give you a data set, and then I want you to take some time to calculate the mean absolute deviation of that data set. Here's your data set. There are 5 numbers, and it's our job to find the mean absolute deviation of those numbers. Remember, I like to do things with tables to keep things organized, so I'm going to draw a table that you can copy into your journal so you can keep your information organized as well. Okay, so remember, the first step that you have to do before you can do anything else is to find the mean of the data set. I'm going to calculate the mean. I'll probably use a calculator. You can too. When you do this, pause the video and then come back and check your answer with me. Hopefully, we all agree that the mean of this data is 24. Now I can use that to fill in my table. We're going to fill that in and find the distance of each number from 24. Again, pause the video. When you're ready, check in and see if we agree. From there, I just have to find now the mean of all of these numbers, right? So make sure you have a chance to find the mean of the distances. Did you get a mean of the distances as 3 6/10, just a little over 3.5? Hopefully, right? Our MAD then is 3 6/10. From this, you should have had a chance to practice the essential question, which was trying to figure out what MAD was and how we calculate the MAD. Remember, MAD is the mean absolute deviation. If you have any questions about any of those things, I know this is kind of a big topic to take on. Feel free to write any of the questions in the margin, and we'll practice more with this in class.